Section 3.2, Functions and Function Notation. First, we need some definitions, and our first one is a relation. A relation is just a set of ordered pairs of real numbers. Remember, an ordered pair has an x and a y, so it's a set of ordered pairs, right? Our next term that we need is domain. The domain is the set of all the first coordinates in the ordered pair. So it is the x's. Range is the set of all the second coordinates in an ordered pair or in a relation. And this is the y in our ordered pair x, y. And so here we are looking at a relation, which is a set of ordered pairs, and they ask us to find the domain. So the domain is going to be all the x coordinates, and we will put it in set notation. If one repeats, you don't have to put it twice. So the one repeats. If we want to go in numerical order, -4 is the smallest, 1 and 2. That is our domain. If you didn't put it in numerical order, that's okay. Right? The range will be the y coordinates. So we have 4, -6, 8, and 5. -6 is the smallest. And 4, 5, and 8. So this is our range. Our next definition is function. A function is a relation in which each first coordinate has a unique corresponding second coordinate, or x cannot repeat. So let's go over it again. A function is a relation. So it's a set of ordered pairs where every first coordinate, where every x has a unique y, right? So the x cannot repeat. Every x has to go with a unique y. You cannot get x going with two different y values, right? So when you're looking at ordered pairs, you just have to remember that the x can't repeat. So for our first one, we're asked, is it a function? We have 3, 4, 2, -6, -4, 8, and 1, 5. Does our x repeat? It does not. It is a function. Right? Our next one, 1, 4, 2, -6, -4, 8, and -1, 8. Does the x repeat? No. It is a function. It is okay for the y to repeat. Right? This one had the y repeating, but it is a function. Our next one, 1, 4, 1, -6, -4, 8, and 1, 5. This one is not a function because the 1, as the x repeats, 1 goes with 4 and 1 goes with -6. So for every x, there has to be a unique corresponding y. This one is not a function. Our next one, 1, 4, 3, -6, -4, and 1, 5. Is this a function? No, because the 1 repeats. It goes with 4 and it goes with 5. So we say no. And our last one, 2, 4, 3, -6, 7, 8, and 1, 5. Does our x repeat? It does not. So this one is a function. We have another way to look at whether something is a function, and this is called the vertical line test. Remember when you have sets of ordered pairs that you can make a picture on the rectangular coordinate system and connect those. And a relation is a set of ordered pairs. So we're working with something that can make a picture for us on the rectangular coordinate system. And this rule says if we can draw a vertical line and it will intersect the picture or the graph in the relation, the set of ordered pairs, at more than one point, then the relation is not a function. So if there's any place on that graph where you can draw a vertical line and it will hit the graph more than one time, then it is not a function because it is hitting two different y's at the same distance across. So two different y's with the same x. Right? So it's just another way to look at whether your x is repeating. Right? And a lot of times the picture is easier to look at to see this. So, vertical line test. If any vertical line intersects the graph of a relation at more than one point, then the relation is not a function. Next, we're going to look at a graph. We're going to determine the domain, the range, and then tell if the relation is a function. So this line is what we're looking at. The other is the grid. First of all, for the domain, this is what can the x be. So remember, x goes across, and this line does continue. So for x, we can keep going forever this way, and we can keep going forever to the right. So the x for the domain, we're going to have negative infinity to positive infinity, or all real numbers. Right? You could state it either way. Right? The range. The range is how does the picture go up and down? Well, if we keep going out, the line is going to keep going up. If we keep going to the left more and more, the line is going to keep going down. Is there any restriction on the up and down part of the graph? There is not. So there is also no restriction on the range. All real numbers, or negative infinity to positive infinity. Right, to determine if it's a function, let's see if there's any place on this graph where we can draw a vertical line and it would hit more than one point. And there is not. We can try all these different places, but it's only going to pass through that line one time. So this one is a function. Sorry, x does not repeat. Let's look at another graph of ordered pairs or relations and see if it is a function. So first we'll determine the domain. Where all can the x be? Well, x is across, so we can actually continue. This picture will keep going up and out to the right and up and out to the left. So the domain, there is not going to be a restriction. So it'll be all real numbers or negative infinity to positive infinity. The range is your vertical movement. You do have a restriction on the range on this graph. What is your lowest point up and down? It is here at 0. So 0 is the lowest vertical point. It is included, so we will use a bracket like we did in the interval notation. But from there, the picture will keep going up forever. So 0 to infinity, infinity always gets a parentheses. Right, and last question on it, is it a function? Is there any place on this picture where we can draw a vertical line and it would hit the graph in more than one place? And there is not. So this one is a function. We'll look at a couple more graphs. This one is a sideways parabola, and you may have to look on your note template for this grid. When we're doing domain, we want where is the x? And right here is the leftmost point. These increments are 5s, so 0 to 25. So each line is a 5. So our x that is the most to the left is at 10. And it looks like it includes that 10. But this picture will keep going forever to the right. So it will go forever, infinity. Our range is our vertical movement. So how does it go up and down? Well, as we go more to the right, it will keep going forever down. Also, it will keep going forever up. So the up and down part is not restricted. And then last, is it a function? Is there any place where you can draw a vertical line that would touch more than one place? And there is. There are lots of places. All you have to find is one. And so this one is not a function. For this particular x value, or this distance across, it is hitting two different y's. So it is not a function. For our next picture, this relation gives us a circle. So first we'll do domain and range. Domain is where can the x's be? Well, our leftmost x is at -3, and our rightmost x is at 3. So this is bounded between -3 and 3. For our range, how much does it go up and down? It only goes up to the 3 and down to the -3. So -3 to 3. And then is it a function? You can draw a vertical line, and that should be straight, of course. But your vertical line is going to hit more than one place. So a circle is never going to be a function.